Sir, ये कट दिसे बोला. So let us know who have not installed that particular software.
Sir, I have not installed it yet.
Why, Gulshan?
Hello.
Sir, I am still downloading it. The network is very poor. Sir, if I could not install it today, sir, I'll rewatch the video and I will do it.
Okay, it's not difficult at all to install that particular software. What you have to do
No,
is
sir, it's
that yeah, it might be problem due to your internet connectivity. But what I want to mean that if you able to install this particular software right now, then it will be better for you to understand how to do that particular objective, which will be assigned as a project assignment or something else like that. So try to do install that software immediately. If anybody left here who has not installed or have not installed this particular, install that software, do it right now. Collect it from Joydeep. Joydeep actually the source of that particular software. This was actually cracked versions. Am I right, Joydeep?
Yes, sir.
Okay. So, but very compatible to Windows 11. So you go for it, or you can even download the student edition, which will be 7-days free. You have to mail some NI software website, NI Communication or National Instrument Communication. They may extend your using durations. I mean, they can use extend that particular license for students. That software is very easy to handle. Not only that, very realistic, and I'm expecting AG sir. Yes, okay, AG sir has joined. So RB sir, AG sir is here. So I'll request RB sir to start that program outcomes. What will be the program outcome of that particular lab, and how many experiments we are going to do. Although that might be given over the syllabus of that particular laboratory, but we may conduct more number of experiments here, as we are doing everything over the simulation software. So in particular 2 days, RB sir and me and as well as AG sir and RB sir will teach that particular laboratory. As far as it is, I was also taught by RB sir when I was student in my department. So that software is today very updated and very user friendly. And I will request one of you to display this one or share this one after RB sir and AG sir. So please, RB sir and AG sir, add something the students, and they can start to share the software over here. We can start all lessons also.
Yeah, good morning, students. It's glad once again to meet you, maybe in online mode. But anyway, we are hoping to that the classes will be started in physical mode. Actually, last year I took this course for the students, but I used some other software. And that I found that there are some errors in the software, and that's why I discussed with Professor Patra whether we can go ahead with some with a better software. Although that was also very friendly. This Multisim, I used it long time back when Professor Patra was a student in our department, and I do not know exactly how to handle it now. So I'll request Joydeep to help me to download the software, and I'll definitely practice the experiments. Now, this laboratory is for this electronic circuits, starting from diodes and transistors, and mainly we'll focus later the operational amplifier part. But since BD sir is taking your class on operational amplifier, then unless and until he covers the basics of this operational amplifier circuits, we cannot start the experiments on operational amplifier. But before that, it's our idea that you should be you should be conversant with the this package, and try to learn the basics of the diode circuits and transistor circuits, whatever you have studied in your course. So, Professor Patra, he has framed some experiments. He will explain on diodes and transistors and some filters, passive filters. So you please practice them, and we'll have after that we can have one viva also. Let us see how we can go about. If the class starts, then definitely we'll have everything in the physical mode. It will be altogether different. Okay, so Arjun, if you want to say something to the students, then we can, then Professor Patra can take up. অর্জুন দা,
হ্যাঁ, ঠিক আছে, স্টার্ট করুন এবার।
okay, okay. তাহলে Shankar, you can start whatever assignments you have thought of.
Okay, sir. Okay, sir. Thank you, sir. Thank you very much. Thank you, research. So, dear students, you probably come across from basic electronics where you are quite familiar, or where you are introduced with some electrical components like capacitor, inductors, and resistors. Might be they all are over the online or over simulations, but I think you can identify them in real world. I mean, when you will be you will be in laboratory, you can easily identify that which one is a capacitor, which one is an inductor, which is resistance. Am I right?
Yes, sir.
Okay, fine. So in that case, you know there is a different kind of capacitors. Uh, can you say what are the kind of capacitor available for our laboratory experiment? So you might have seen some kind of paper capacitor or non-polar capacitor or some cylindrical shape which is polar capacitor.
Non-polar and
Am I right?
electrolytic. Yeah.
Electrolyte.
So there's many types of capacitor available for doing some electrical or electronics laboratory. So remember them all. But in our laboratory, you will be habituated to use paper capacitor or non-polar capacitor, polar capacitors. Okay. Similarly, you will find there will be inductor, but inductor is a very bulky component. It's not a small in shape like capacitor or resistance. So in that case, you will have a very less number of inductors in our laboratory. But definitely there will be inductance if required for your circuits. And as you come across some circuit theory, so you are quite familiar how the resistance, capacitors, inductors are connected. Sometimes they will be parallel, they will be in series. On there is different kind of connection, different kind of connections might be series, parallel, combined in different kind of circuits. Am I right?
Yes, sir.
Yeah, fine. So in that case, you probably can find out you found out that equivalent resistance or Thevenin resistance, Norton resistance, or Norton impedance. That kind of things you need in circuit theory paper theoretically. Am I right? Yes, sir. Okay, very good. Now we are going to do some kind of circuits over here with starting with resistance and capacitor. Have you started with the passive filter earlier? Any circuits with a passive filter? Passive filter means R and C both are connected, might be in series, might be in certain kind of P or H connections. My base-shift oscillator, phase-shift oscillator. Have you done that experiment over simulations?
No, sir, only theory. Okay, only theory.
Very good, very good. So look, this kind of circuits we can do. What is the purpose of filter? Probably in fundamental of instrumentation, I have told you that there will be certain kind of electrical signal conditioning circuit, signal processing circuits, conversion circuits like these circuits where the resistance or resistance inductance or resistance capacitors are used as a AC bridge in the AC bridge one like sharing bridge, A bridge. And similarly, there will be some kind of resistance bridge, a Kelvin double bridge, or Western bridge. All those kind of bridge are there also, and those kind of concept of bridge circuits are heavily used in instrumentations. When I discuss about the block diagram instrumentation, you have seen there uh, some amplification circuit as Sarge told just few minutes back, where the operational amplifier are often used as a inverting op amp or non-inverting combinations, connections, configurations, inverting configurations. So these are the circuits also required for the instruments when we are going to develop or design. But I don't know that whether all of you are going to design that kind of instrument, but you should have the idea how the circuits are used to process signals that coming from primary sensing elements. So the RC filter is very important there. RC filter are mainly passive filter. When we use some active component like operational amplifier, that filter will be called active filter. I told you there will be several kind of filters. There are starter filter, filter, not filter. But this is before this one I have not studied that clearly. So we will go for passive for RRC be connected in T model and pi model, and we will find that how the signal, different signal, kind of signal means the signal having a different amplitude as well as different frequency. When they will be allowed to pass through that particular filters, we will study that how that voltage, frequency characteristic of the or frequency response of the particular pi watt D model of R filter. Yes, probably I told you that there was a certain kind of first order shift and second order system in other circuit like fundamental of instrumentation. Am I right?
Yes, sir.
Yes, sir.
I'm not getting first and second systems. I have shown you that R and C combined will be considered a first order electrical circuit. R and C. Can you remember the circuit RC? What tau was the time constant?
Yes, sir.
Yeah. Sudha Satto and Anujita was there. Jordi sometimes was there also. I expect that you can remember them. So that was the first order system. So our RC filters and different kind of signals will be inputs to that particular RC filter, and let's see what the frequency response or amplitude response of that RC circuits over the analog over that particular software module. So what we have to do, we have to connect a function generator with the RC configuration, then we will find that output. Output means might be seen through what? Output might be seen as spectrum analyzer, output might be seen here. So one of you, I'll say that Sikha Sahab, can you please show the or share your computer skills while you have installed that particular software Multisim?
Yes.
Okay, share it. Today you have to share, and you have to, all of you have to focus over that presentation of Sika here and learn how the software will work on. Next, I will choose someone from you and have to show that particular experiment how you have to do. Very, yeah, it's fine. It's fine. So look over the screen. Everyone, look over the screen. You will find here just third level. I mean third level down from file, edit, view. Third level down. So you find here some symbols of the just below, just top of that hand. There are certain kind of components. Just first one. Come here. Yeah. Just click on that particular symbols. Click, Sika. Very good, excellent. So here you will find a pop-up or sub window where you will find the sources. So sources here, look, power supply, power sources, signal voltage sources, signal current sources, controller voltage or control voltage source, control current source, control function blocks. So many sources are here. Even you are going for the power sources, click on the power source. Very good, very good. So you will find here the component, list of components which will be available over here in a some symbolic mode. Look, those symbolic modes actually helps you to design that particular circuits. But when in real time, when you are going to design that circuit over the laboratory, you have to choose that particular kind of component available in our laboratory as instruments. Okay, like here AC power source, DC power source. In our laboratory, you will find also DC power supply, AC power supply, or any function generators. So these are the component you will, but we don't expect that you will be supplied with the ground. Ground means there will be certain portions you have to consider over the circuits. There will be opposite of the positive side. I mean negative side will be ground. Consider will be ground, and some circuit boards are also given in our laboratory. The grounds are different. Digital grounds and one is analog grounds, and also you will study the virtual grounds that will be discussed in operational amplifier. Probably I have given a little bit idea about the virtual ground when I have explained signal and conditioning circuit. Am I right, Suraswata?
Yes, sir.
So I want to hear from you.
Sir, I don't have my device with me right now, sir. I'm connected to the phone. I don't have my laptop with me right now.
Okay, fine. So look here, AC port and DC port. So you can choose any one of that power. Sika, can you hear me? Click on
Yes,
the
sir.
AC port and OK. Then OK. Go for OK.
হ্যাঁ স্যার ওকে করেছি তো।
হ্যাঁ OK করো, ক্লিক করো ব্যাস, দেখো আবার এসছে। Definitely you need a ground point also here. Don't need to click on that, click করো, ঠিক আছে? Stop doing anything. Again, ওই ওখানটায় যাও, ঠিক আছে? Just blindly follow me. Don't do yourselves anything. Get my point, Sika?
ইয়েস স্যার।
Sika, don't do anything. Just blindly follow my words. So as you have chosen a power supply, you need to use a ground. So you go for the ground here. This is the fourth item of that component list. That component list at the middle of that sub-window. Go for this one. Select and OK.
স্যার এখানে কোনটা?
Select.
গ্রাউন্ড।
Okay. Yeah, ground. Click on that board.
অনলি ক্লিক।
Click on that board to click. You did it when you have chosen supply.
স্যার শোনা যাচ্ছে না, মাঝে মাঝে কেটে যাচ্ছে।
Just click. Why you are so slow? Yeah, your computer is slow. Is it?
No, sir. It's good.
Okay. Don't do VE. At the bottom of the component list, DCC and VE. And
VCC में sir.
Sir, your voice is breaking very often, sir.
अबे यार ऐसा कैसा चलेगा?
sorry, Sika, can you say it again?
Okay, sir.
So as I told you, Sika, BCC and VE at the component list. Go for them. BCC and VE. Okay, click on OK. Very good. Put over the board somewhere here, left side or right side, and VE. Okay. So look students here, please. So now you have chosen 5 components. Very good. Okay, fine. Just right click on that. Right click on that. You can delete. Very good. Delete here. So you have chosen 3 sources here: DCC, VE, as well as AC supply, and where the RMS value is showing over here with a certain frequency, and there is a ground point. So these are the sources you have chosen. So while we use VCC and VE, can you remember? Prosenjit Mondol. Prosenjit Mondol.
Yes, sir.
Can you tell me where you have used VCC and VE?
I see. No, sir. So I might forgotten this. It's a transistor. A transistor.
Just try to do a transistor circuit, or in diode case, I don't know the op-amp was introduced to you or not, but in syllabus probably there is an introduction of operational amplifier. But in that case, we also find that DCC and VE will be considered as a DC supply to the operational amplifier. But in case of transistor, definitely we have studied that DCC and VE. Okay, so these will be the sources when you are going to design a transistor circuit. When you are going to use a DC supply, AC supply like here, Sika, will you click on that AC supply? Right click on that AC supply. AC, not VCC. Yeah, this one. Right click. Okay, you will find many things over here. Click on the properties. So look here, you can change the value. See, AC power and the value also giving. That value means RMS value. It was shown as 120 volt. You can make it 10 volt also. If you want to make it 5 volt, you can do it. So better you change it 5 volt. Tika,
Yes, yes.
5 volt. Thank you. Very good. And frequency 60 hertz. If you want to change the frequency to 1 kilohertz, what you have to do? Make it make it 1 kilo. Very good. So this way even you can change the value of the power supply. Might be you need a 5 volt AC supply, you might have a need of 5 volt AC supply with the 60 hertz, with the 10 hertz, with the 5 hertz, with something else. So you can do it here. Not only that, even you can put some kind of tolerance. Tolerance means some, real time when we are going for a power supply, we expect that 5 volt and 50 hertz or 1 kilohertz will be the source as you have fixed. But you will find the real signal is not like that you have fixed. There will be certain change in the signal. Those sources are not precisely designed. So that kind of problems will be there. But in that case, what you have to do, you have to consider certain kind of tolerance. The expected tolerance there will be within 2%, plus minus 2% to 5%. So that kind of tolerance you can put it over here. That will give you a almost real power supply that we use in our laboratory. So if you want to put tolerance, you can put tolerance over here, 2%, 5%, whatever else. So these are the component you need to change, like a damping factor. Even if you need to design a circuit with a certain damping factor, you can do it. But right now you don't need to change those parameters. You can go for the simple AC power supply with a certain value of RMS value and might be or RMS value like here as well as frequency. So okay, that's that. Please click on that. Okay, good. So these are the supplies. Similarly, click on the click on the VCC. Go for the project properties. Look here, the VCC is a 5 volt, but in case of operational amplifier, you will find that the VCC might be 12 volt or 10 volt. There will be plus VCC and minus VCC in transistor BJT as well as operational amplifier. So V is given for minus parts DC supply, and DC is given for plus DC supply. So the value you can fix yourselves like 5 volt or 10 volt or 15 volt, whatever you want to do. Okay. So click on the OK. Even you can name them A, B, C, whatever you want to do. Just go for the next component after the sources. Sika, come back over here. Next component, right here. Good. Place basics. Look, now you have come to that particular component. Components means what kind of component you want to use, like transistors, like transformer, like inductors, resistors, so whatever you want to use to design a circuit, you can select from here. Like the first one is given here, basic virtual. So some kind of virtual circuits, virtual components will be given, where the details of the components are not display, will not be displayed. So that is the virtual one. But then after you will come to the PDAC switches. Let's come back to switches. So there are several kind of switches. Look, DIP switches. Just don't click on that particular setup, but you can select any one of them. Just any one of them. Rest of the components. DIP, okay, fine. This is DIP switches. Look, this kind of switches even available in our laboratory. Earlier, there was a big switches, like that kind of DIP switches was there to make the connection sorted or make the connection open. But today, these are the circuits. These switches are very smart over here, over in our circuits, real-time circuits design. But when we are going to design a circuit, we can put that kind of switches for our connection. So several components are given. We will go for the simple one for our design. Similarly, transformer. You please go for the transformer. Next option. So here, look, there is a simple transformer. The primary side and the secondary side was shown. Probably transformer you studied in basic electrical. Am I right? Ashraf?
Yes, sir.
Ashraf,
Yes, sir.
have you studied transformer?
Sir, I've forgotten. No,
Yeah.
sir. Yes, sir. I've
I'm
studied.
not asking you the questions. I'm just asking, have you studied it?
Yes, sir.
That's enough. Okay. So there will be a center tap transformer also. Sika, can you help me to find the center tap transformer? Go for any one, two, three. Those are the kind of transformer. Go for the. These are the also kind of transformer. Go for other. Go for other, Sika.
This one actually.
Yeah, this one actually. There was a two secondary coils over the primary coil, and definitely over the two secondary coils. Actually, this is not a two secondary coil. The virtual design is that two secondary coils. Actually, the primary sides are there, also secondary side was there, and from the secondary side, middle of the secondary side, a center tap. Right. So this transformer is look like a center tap transformer, or will be used for center tap. Have you studied center tap transformer in diode circuit or rectifier circuits?
Yes, sir.
Very good, very good. So this center type transformer can be used for our particular designing of rectifier. Okay, that is a very simple circuit. Half wave rectifier, full wave rectifier, bridge rectifier are there. We can design and come back to the non-ideal RLC. Better non-ideal RLC is go for the relay or some kind of resistor, capacitor, inductor given over here. Please, Sika.
Sir, what you say?
Come back over here, resistors and capacitors just below. Look, this is the resistor and the components having defined values. So defined values means one resistance also there, 220 ohms resistance, 100 ohm resistance are heavily used in our laboratory. In mainly 100 ohm resistance, 220 ohm resistance, and 1 kilo and 10 kilo potentiometer are heavily used for your analog electronics laboratory. Except them, there was also other resistance, and there are also certain color code, huh? And that color code should be easily remembered by certain statement. Can you remember that statement?
So
Yes.
the joy of Great Britain had a
Very good, very good.
wife.
So, Roy of Great Britain.
Had a very good wife.
Anyhow, so that is the first letter of the every words actually represent a color,
Yes.
right?
Yes.
So using that terms, you can easily identify which kind of resistance you are going to use for your designing circuit in real time. Real time, when you will be in laboratory. So remember, this kind of questions easily asked in your Viva. Can you remember this is the resistance and there is a certain kind of color? Can you say what is the value of the color resistance? What you have to do, you have to remember that particular statements and you have to find the value according to the color of the resistance. This is the right answer when you are going to ask for the value of resistance showing you particular kind of resistance. So remember this statement for your Viva, and as well as do certain kind of practice how to remember how to calculate the value of resistance. And the next point is the capacitor. So this is the capacitor 0.47 microcapacitor is very heavily used in our laboratory, as well as pico capacitor also used. So look, we are 1.0 microfarad. That is farad. Farad actually the unit of capacitor is farad. Am I right?
Yes.
You know this one?
Yes, sir.
Yes, sir.
Okay, very good. So that micro means that micro is not a unit. Microfarad is a unit. Nanofarad is a unit. Picofarad is a unit. So those are the value of capacitor which will be considered for our circuits. And inductor. Come to that next point, next component. So this is inductor. Look here, several value of inductor. What is the unit of inductance?
Henry.
So
Henry.
Very good, very good. So Henry will be the unit of the inductance. So we can choose any value of the inductance over here, and according to what we can design our circuit. But definitely we will help you to know that what is available inductance in our laboratory. As is, whenever or whatever you are going to design, you can make that design in the real when the offline class, in offline class. Am I clear?
Yes.
Okay, better. So now, Sika, I will request you to select one of the component from resistance, one of the component for capacitance, one of the component for inductance.
Okay, sir.
Yeah, yeah. Okay, and put on the board. Okay, put on the board.
Okay, sir.
That's very easy. Just simply click on select, click, and okay. Very good. Excellent. Well done. So now these are the component. Now come to the next one. Just next of the place basic. Yeah, right. So look here, you will find some kind of diode circuits or diode track, SCR, director. So many things are given over here, and they are corresponding some values or some names which are available in the market. Okay, like in diode, go for not for the virtual diode. Next one, real diode. So look here, we normally use IN4007. Arbi sir?
Yeah, actually it is 1N4007, and I'll tell you the explanation why this is 1N. You will find that in many components the first this thing is either 1 or 2. If it is 1, then it indicates that there is only one junction. So the diode names it may start with 1, although there are other nomenclatures. And for transistors, you will find it starts with 2N. So just looking at the first character, you will understand whether it's a diode or a transistor, right? So you select one in 4007 or one in 4001. That depends upon the current carrying capacity.
Hold
Yeah,
on.
Prashant, please continue.
This is IN4007.
IN4007. You just hold on, you will find some component IN4007 or 4009 as I've told. Yeah.
4009.
So is it okay with IN1 and 4009?
That we have to check that. I think that should be okay. One in 4009 will have a higher this current carrying this thing. You are not finding one in 4001 or 7 or any number less than that.
4007 is there.
7FHC or 7EC or 54, etc.
No, 4007 is okay.
Yeah. 4007 is okay. Actually, there is one website. It's called alldatasheet.com. There you can find all the details of these components. What is the current carrying capacity? Only the current carrying capacity is more if the number is higher. And in that case, the problem is that the capacitance that also that effect will be more in that case if the current carrying capacity is higher. So.
So এখানে only one in 4007 নেই।
You use this one, there's no problem. 1 in 4007.
It's okay. So G stands for company names probably.
Okay.
So this one.
Yeah. Click on OK. 1400G. Go for 4007G.
Okay, sir.
It's only German company.
Okay, sir.
I'm checking its manual details over here. It might be a Java coupon. So as sir told, its function is same. Still, you click on that, right click on that components. Go for the property, and you will find details over here. Uh,
Well, you can see only the property, but you cannot change it.
no, it can be changed. Right, sir. Right, sir. So you will find the details over here, like it was given what is the package and manufacturer. That might be in details, or even you can select that particular component over your Google, so you will find the details of, I mean, the detail sheet of on that particular components. So click on that OK. So this is the diode. So you got a AC supply and diode and some resistance. So what you can do? A simple half-wave rectifier. Am I right? Let us do it. Sika, click on the VCC and V and make them all deleted. Just go delete them. Select all. I mean, right. Delete. Okay. Just drag that component to your left side. As well as drag that ground to your left side down. Okay, fine. Down. Just put it down. Okay, fine. Just select on that particular terminal. Select the terminal. Just move your mouse here. In terminal of the ground. Click. No. Click on the in terminal. Okay. click করো। ক্লিক করো আগে ক্লিক করো।
হ্যাঁ করেছি।
হ্যাঁ এবার ওর উপরে নিয়ে গিয়ে কানেক্ট করো। জাস্ট কানেক্ট।
Sir, I can do one thing.
No, not this way. Don't do this. You have to use the connection. This is a good practice. You can make them join this way. Use wire to connect them. Select and connect. Very good. Now you go for the diode here. Bring the diode here. Here, at the top, not too close. Keep it far away. So connect them. Plus VCC connect with this one. Very good. Bring the resistance here. Not too close. Right click on that. Make it vertical. I mean 90-degree clockwise. Rotate. Very good. Connect the terminal with the diode and resistance. Okay. At the end terminal with the ground. Am I right?
Yes, sir.
Is it should be connected with the ground? Connect with the ground. Click on that red one. So, okay. Is this circuit is right or wrong? Say, tell me someone. Obiru?
Yes, sir. The circuit is right.
Connection is good? Right?
Yes, sir.
So, what do we expect across resistance?
Sir, a half-wave rectifier circuit.
So, how can you see this one?
Sir, using simulate.
Using?
So, the simulate option.
No, not that word particular simulate. You have to use certain instrument. Can you name it?
আউটপুট নিতে হবে।
Tell me, Rajiv.
Sir, we need to use a probe.
Use a probe means what kind of what is the probe here? How can you monitor? Is that a half wave or full wave?
Sir, CRO.
Oscilloscope.
Sir, function generator.
Function generator.
Let me ask Mustafa Kamal.
Sir,
Right,
oscilloscope.
oscilloscope. So where you will find oscilloscope? Sika, just at the right side of right side, come back to right side. Just complete right side here. Here at the bar, right side bar. No, down. Come here, come back at the right side. Scroll bar, near the scroll bar. Okay. Those are the monitoring instruments. See, this is a function generator, that's also a source, not a monitoring instrument. Those are the heavy instrument you can say. Multimeter, you can select a multimeter. You can select a function generator just below of that multimeter. And below of that, there is a CRO. Go for the CRO. Now, watt meter and oscilloscope. Look, oscilloscope. So you can select one of them, like multimeter and oscilloscope, or even both. Go for oscilloscope, drag it down there. Very good. Very good. And a multimeter. Even you can need a multimeter here at the top. At the top. Click on it. Okay, look. At the downside, come back over that scroll bar. Over the instrument list. At the down. Go down. Go down. Go down. Look, here is some kind of multimeter, Agilent multimeter. Have you seen there? Just click on that Agilent multimeter. Click on. Just top of that. Click on that. Put it here. Double click over that Agilent multimeter. Look, this is the actual Agilent multimeter looks in our laboratory. Do you understand? This is actual multimeter panel. Agilent multimeter panel. It might be cost nearly 1 lakh. Sir can say the exact amount of these instruments. Uh, I might be wrong here, but this is the actual Agilent multimeter looks like.
Yeah, we have only one such instrument, expensive instrument in our lab, and that costs more than 1 lakh of rupees. But its precision and accuracy is very high.
Okay. Sika, you can go for the next one component here. Next component here means after the Agilent component, go to the next one. Lab view instrument and down. Click on that. Look, here is a certain kind of instrument which is impedance meter, microphone, speaker, signal analyzer, signal generator, spinning signal generator. So many components are also here, and I have also seen there is a certain kind of Agilent oscilloscope. Sika, can you go back to the oscilloscope? Some here, it might be hidden somewhere. There will be a Tektronix oscilloscope and Agilent oscilloscope. I have seen in my student edition version that two instruments also given. Scroll back. No. Anyway, click on that oscilloscope. Double click on that oscilloscope. No, this is simple oscilloscope. I mean virtual oscilloscope. Anyhow, in that oscilloscope, look over here. There is some kind of time divisions at the bottom. Bring your mouse here. This is a time division. So what we used to do, we have to rotate the particular knob of the CRO to change the time division, time per division. Am I right?
Yes, sir.
Right. So what you have to do, you have to change the value. Like 10 millisecond, you can change it to 2 millisecond or 1 millisecond or less of that. And similarly, in channel V, when it will be connected with the channel V, you have to change that voltage per divisions. Like here, voltage per divisions. Voltage per divisions mean over the CRO there is a Gatti tools. Okay. So over the Gatti tools, the each and every square, smallest square will be considered as a part divisions. A divisions. Okay. So when you are going to select some kind of scale like here, so part division will have a certain value. Like here, 5 volt. If you are going to change it 1 volt, you can even change it 1 volt. Then what happens? The waveform will be look bigger. So you have studied the CRO in measurements, so you can easily understand how that CRO can be operated. But here, just look over that some channel A and channel B. What you have to do, you have to change the scale per divisions, change the scale of per divisions and voltage per divisions, and here the time base you have to change. That's all you have to change to get the waveform over the display. Okay, Sika, can you close it? Very good. So what you have done, you already make a circuit. So what you want to see? You want to get a connections from where? From the inputs of the diode. Inputs of the diodes means input side of the diodes. That's mean it is the output of the source, output of the AC source. So bring a particular one. Okay, just bring the oscilloscope here. Here you will find channel A and B, both are given, right? So channel A, positive side, just you have to connect the positive side. Connect, click and connect here at the output of the power supply. Move up. Move up, just go straight. Go straight over the connect. Don't worry about the lines. Go and stay connect with the output of the power supply. Sika, you are just out of track. What happened? Why you are so worried? You, just drag it to connect there. Simple.
Yes, sir.
Move up at the output of the power supply. Is that output? That is the ground point, no? Okay, connect there. Alright, just move up little bit, move up little bit and connect there. Very good. So it's connected. What happened? Now you can see the input signal over here. Just Sika, move here, download the option button. Move up, yo, move up at the top. Go to the top. Don't click over the oscilloscope. Come here, come back here. Top, at the top. Move up. That is green button. Green button means it's a run button. Yeah, click on that. Once you click, that's when the power supply is active now and it's forcing a signals through the diode and resistance, then after ground. How can you see this one? Click on the oscilloscope, double click on the oscilloscope. Look, this is the waveform you can see here. Now what you have to do? Somebody say me here, what you have to do to see that waveform? Just pause it. Near the run button, you will find a pause button.
Sir, time division change korte hobe.
Right, boy, right. Just
So that time.
okay. So Sika, what is the solution from your friend? You have to change the time division to see the waveform. Change the time divisions. Very good. You're doing right. Change it. Change it. Make it down. Value it down.
Yes, sir.
No, not this way. Just edit here. It's a make it keyboard. 1 millisecond. Yeah. Delete.
Until
Backspace.
স্যার হচ্ছে না ব্যাকস্পেসে করছি
স্যার অ্যাপ ডাউন এটা করতে হবে।
সাইড এরো আছে দেখো। এইটা পাশে এইটার কাছে গেলে যাও ওখানটা যাও। হ্যাঁ, এই যে দুটো আছে ওর নিচেরটা যাও।
এখানে
যাও এই যে ওখানটায় যাও, ক্লিক করো। এখানটা কেন করো? এটা এক্স ফাংশন দেখতেই পাচ্ছ, কিন্তু স্কেল চেঞ্জ করছো। হ্যাঁ, ক্লিক করো করো। এই যে এই স্কেল দুটো, এই যে দুটো
স্কেলের পাশে একদম দেখো চেক করো।
আচ্ছা
ওইটা থেকে নিচে
এটা বাট কমাও কমাও কমাও, ব্যাস, রাইট। কিপ ইট হিয়ার, ডোন্ট মেক ইট মোর। একটু বাড়াও, আরেকটু বাড়াও, এটা ফুল ওয়েভ ব্যাক করো। হ্যাঁ, ব্যাস। So this is the waveform. You can drag the display, make it big. কোন একটা কর্নার ধরে এটাকে একটু পুল করো, বড় হয়ে যাবে। ওটা নয়, এই ওয়েভফর্মটাকে, এই পুরো ডিসপ্লেটাকে একটু বড় করা যাবে। আচ্ছা ঠিক আছে, চলে যাও। দিস ইজ দ্য ইনপুট সাইড। এইটাকে তুমি সরিয়ে ওদিকে রাখো, সিধা পুরো অসিলোস্কোপ ক্লিক করো। অসিলোস্কোপ লেখা আছে এখানে, ক্লিক করো। এটাকে পুরো সিলেক্ট করে উপর দিকে তুলে দাও, ড্র্যাগ করতে হয় উপর দিকে তোলো, ওইদিকে ডান দিকে উপর, ডান দিকে। আচ্ছা ঠিক আছে, ঠিক আছে। হ্যাঁ, what you have to do right now, you have to check the output of the, I mean, voltage across resistance. As your friend says, it will be half wave. Let me see. Connect the output of the across resistance to the CRO. How can you connect it? Now, B থেকে নিয়ে আসো, B থেকে নিয়ে আসো। কিন্তু বিটা থেকে, হ্যাঁ, বিটা নিয়ে গিয়ে কানেক্ট করো। উপরে করো না, একবার মাথায় দিয়ে দিতে হয়, কি বলছে, উপরে করো। তাহলে
ঠিক আছে, এটা
রান করো, দেখো ঠিক আছে। ভুল হলে যা হবে প্র্যাকটিক্যালি বুঝতে পারবে। রান করো। আচ্ছা, তুমি এরকম ওয়েভফর্ম পেয়েছো, পজ করো, পজ করো। ওটা স্টপ করছো, তুমি পজ করলে পাশেটা করবে, মাঝখানেটা করবে।
আচ্ছা, ওকে স্যার।
পাশে রান করো। রান করো, আরেকবার রান করো, পুরোটা রান করো। হ্যাঁ, এটা রান হোক, এবার মাঝখানে যাও। এবার পজ করো, কোন একটা জায়গায় ফুল ওয়েভটা দেখতে হলে পজ করো। আবার রান করো, পুরোটা না দেখতে গেলে কি করে করবো? না, এবার পজ করো, পুরোটা দেখা যাচ্ছে না, তখন পজ করো। এবার নিয়ে এসে ওয়েভফর্মটা নিয়ে এসে মাঝখানে নিয়ে এসে ড্র্যাগ করে নিতে হবে। এবার তুমি এখানটা দেখতে পাচ্ছ তো, তুমি চ্যানেল এ তে কি দিয়েছে, ইনপুটস। চ্যানেল বি তে দেখছো আউটপুটস অ্যাক্রস দ্য রেজিস্ট্যান্স। তো তুমি এখন আউটপুটটা দেখতে চাও কি হয়েছে, তাহলে চ্যানেল এটাকে তোমাকে কমাতে হবে। তুমি চ্যানেল এটাকে 0 করে দাও, বা 5 ভোল্টটাকে তুমি কোনোভাবে এটাকে অফ করতে পারো। তুমি 0 করো, এই যে 0 আছে, এসি 0, ডিসি 0 করো, নিচে নিচে।
স্যার, এটা 0 তে করা আছে। আচ্ছা,
0টা ক্লিক করো। কোথায় 0 তে ক্লিক করো, 0টা ক্লিক করো। এটা হয়ে গেল, অফ হয়ে গেল, চ্যানেল এটা অফ হয়ে গেল।
আচ্ছা।
হ্যাঁ, এবার চ্যানেল বিটাকে দেখতে পাচ্ছি। যেহেতু তুমি পুরোটা নাও নি ওয়েভফর্মটা, তুমি এইখানটা দেখো, এই ডিসপ্লে, কালো ডিসপ্লে নিচে একটা স্ক্রল বার আছে, বার নেই, এই স্ক্রলিং এটা অপশন আছে, এই যে ডান দিকে। হ্যাঁ, ওটাকে টেনে নাও, ওটাকে টেনে নাও, এটাকে ড্র্যাগ করেও মাঝখানের দিকে নিয়ে এসে পুরো ওয়েভফর্মটা দেখতে পাচ্ছি। হ্যাঁ, so can you see here, is it a half wave?
Yes.
Is it half wave?
Yes, sir.
So this way you can see, look, you have to do certain measurements here, that is it actual output, which I have given, output means according to the amplitude, according to the frequency, whatever you have given as the input signal. So what is the output here? What about its amplitude, what about its frequency? So this is half wave rectification. You can see the waveform. So can you design the full wave rectifications here, similar way?
Shankar, just I'll interrupt here. From this diagram, from this waveform, we can also find out what is the diode drop. So, will you please make it the channel A also on, and then we can see the difference between the peak value. You make it DC channel A. No, right side DC. DC coupling. This is basically coupling. So either it's AC coupling, ground, or DC coupling. Yeah. You click to DC. Yeah. Now you see there is a slight difference between the input wave and peak value of the input wave and the output wave, and that is due to the diode drop. That also you can measure hmm, from this waveform. Okay, Shankar, you can now continue with the full wave rectifier.
Okay, sir. Okay, sir. Sir, this is the example how to design the half wave rectifier. Now, make it close.
Hello, sir.
Okay, Raju, tell me.
How will we measure the drop from this diagram from the oscilloscope that we are getting here?
You have to observe that waveform, right? You make it big and
Yes,
consider
yes.
as we have defined the division per division voltage per division.
Okay,
You
sir.
have
That
to
one.
this
Okay.
one.
Yes.
So stop that circuit. Stop that circuit. It is paused. It is not stopped. Sika, stop it. Right. Good. Very good. Now, can you design a RC first order systems or RC filter?
Yes.
As you discussed, what you have to do? What you have to do? You have to remove, replace the diode by.
Power resistor.
Okay, replace it. Take it that. So this is today is just simple discussions, and I'll give you some kind of assignment here. As you can do it yourself and go for measurement as sir told. Some parameter you have to specifically measure and have to find that value over the lab report. AG sir or a RG sir will say you how to prepare your lab report over here. So this is R and C. So in case of passive filter, you know there is a certain calculation of cutoff frequency. Am I right?
Yes, yes.
Yeah, you have to do that cutoff frequency calculation over here, and you have to check whether that cutoff frequency is achieved by your circuit or not. Okay. So can you run that circuits? No. First let me expect what your expectation here. What kind of filter is it? Is that a low pass filter or high pass filter or band pass
High
filter?
pass filter.
It's a high pass filter.
So is it high pass filter? Then what should be the cutoff frequency of? Is that a lower cutoff or upper cutoff?
Upper.
In high pass filter there is the upper cutoff.
Lower cutoff.
Lower solo.
There will be lower cutoff. So lower cutoff. What should be the lower cutoff frequency according to your design?
So 1 by RC.
So 1 by 2 pi tau s.
1 by
2 pi to time constant.
2 pi tau s. Is it?
Yes, sir.
Hmm?
The time constant tau s. Open circuit.
1 by RC.
Okay. So how can you find this value here? What is the way to calculate the value? I mean, derive the value. Derive the expressions of frequency here. Cutoff frequency here.
So from transfer function.
Transfer function মানে voltage, input voltage,
Output by
output voltage থেকে বার করতে হলে output voltage by input voltage. Am I right?
Yes, sir.
So output voltage means across resistance. Yeah. You have to go for the Laplace transform of the output voltage by input voltage. Then you will find the transfer function from where you can calculate the cutoff frequency. Am I right?
Yes, sir.
Oh, very good. So check out that or yourself. Just go for the calculations. So as you said that it should be high pass filter according to you. I'm not going to say anything here. Check it out. High pass
Sir,
filter. Uh-huh.
sir, this is connected across the capacitor, so it will be a low pass filter. Resistance across connect করলে high pass filter হবে.
Okay, you might be some of you might be right, some of you wrong. Let's see practically what happens. So click on the oscilloscope, run the circuits, and change the frequency of the power supply as you wish to check whether it is a high pass filter or low pass filter. Click on the power supply.
So high pass only, sir. Not low pass.
Click on, double click on. Okay. Just move the slide at your right side, Sika. Run the circuits. Look, you are finding two waveform here. Okay. All you have to do, pause the circuit or stop the circuit, change the frequency of the power supply. Here. Click on the power supply. Go for the power supply. Right click on the power supply. Right click on the power supply.
Here.
It's 5 volt RMS 100 Hz, 1 kilohertz. Huh? Click on that. Change the property. So frequency is 100 kilohertz. If you want to check exactly the low pass filter, it should be low frequency should be allowed. Make it as low as you can. 10 hertz. Don't make it 0. 10 hertz. Okay, click on that OK. Run the same circuit. The outcome is okay. Same. Stop it. Make it high. High enough. Or frequency. Change the frequency of the supply. No, that 1 kilohertz you already taken. No? You make it 10 kilohertz or 100 kilohertz. কত নিয়ে নিল? আচ্ছা ঠিক আছে, click on that. So how can you see that waveform? Stop it or pause it. Sika, change the time base.
What's that?
Time base. Of oscilloscope. আরে তুই নার্ভাস হচ্ছিল এখানে
না স্যার কি হয়ে গেল?
আচ্ছা এটা আছে উপরে আছে। তুমি টাইম বেসে আছো, এই যে টাইম বেস লেখা আছে
কোথায়?
ওই যে স্কেল দেখো না, ওইটা চেঞ্জ করো।
হাই করব?
তুমি কি হওয়া উচিত দেখো সেরকম করো। করো কমাও আরো কমাও।
হ্যাঁ স্যার, হাই পাস করতে হচ্ছে।
হ্যাঁ দুটো কি এসি তে করো? ওটা জিরো করছো, এটা এসি করো,
এটাও এসে?
হ্যাঁ আচ্ছা এই কোনটাকে এদিকে সরিয়ে আনো তো। রান করো। পজ করো না। দেখো এখানটায় কোনো একটা বোর্ড চেঞ্জ করলে তুমি দুটো ওয়েভফর্ম দেখতে পাবে। আর এখানটায় ভ্যালু কি দেখাচ্ছে, চ্যানেলের রিডিং কি দেখাচ্ছে, দুটোই সেম দেখাচ্ছে।
হ্যাঁ স্যার, দুটোই সেম তো।
আচ্ছা, আরেকবার ক্লিক করে রিস্টার্ট করো তো, সিস্টেমটাকে রেখে দাও, আরেকবার অফ করে রান করো।
স্টপ করব, তারপর রান।
এর মধ্যে তোমাদের একজন একটু কাট অফ ফ্রিকোয়েন্সি ক্যালকুলেট করে বলো। রান হয়নি, এখন স্টপ হয়নি, স্টপ করে একবার।
আচ্ছা, সরি স্যার।
স্টপ করে দেবো
স্যার
এখানটা।
দেখা যাচ্ছে না স্যার।
হুম, ঠিক আছে, বুঝতে পেরেছি। একটু এদিকে আসো, এই ডিসপ্লে থেকে একটা স্পেকট্রাম অ্যানালাইজার, অসিলোস্কোপ নিয়েছো তো, একটা স্পেকট্রাম অ্যানালাইজার।
স্যার কেটে দাও, স্টপ করব।
কেটে দাও, কেটে দাও। দেখো একটা স্পেকট্রাম অ্যানালাইজার।
স্যার কোথায়?
নিচেরটা কি আছে গো, নিচে একবারে নিচে
কারেন্ট প্লেন।
এখানে স্পেকট্রাম অ্যানালাইজার দেন, উপরে দেখো দেখি। আচ্ছা, ওকে, তুমি এক কাজ করো, and to calculate, somebody just go for the calculation of the cutoff frequency of that filter circuit you designed here, and according to what we will supply that frequency here. Okay, and replace the power supply here by function generator. Sika, bring a function generator here. At the right side you will find function generator. Next, click on that, bring it here. Bring it here, your left side. Double click on that. So you will find what kind of signal you are going to select. It's a sinusoidal signal, there will be triangular signal and square wave. So as well as in our laboratory, we find similar function generator there also, and having three kind of signals: sinusoidal, square wave, as well as triangular. And what you have to do, you can select frequency as well as its amplitude. Okay, amplitude means voltage, peak to peak voltage. So you just replace that power supply BRMS by as a function generator. No, not this way. There is also ground point and positive, negative. There are also two points. Connect. That plus point should be connected right top. Don't put it in this circuit. You can keep it out of the circuit and bring that connection here. A common point can be connected with ground, but not necessarily. Function generator itself having a ground point, you can connect this one with the ground.
স্যার কাট অফ ফ্রিকোয়েন্সি 400 হার্টজ আসছে।
400 হার্টজ না? আচ্ছা দেখছি না, এদিক দিয়ে পাওয়া যায় কি।
Yes sir. হ্যাঁ স্যার 400.
Is that a low pass filter?
No sir, high pass.
So Rajdeep have calculated this is a low pass filter. Am I right? Rajdeep, you told it low pass filter, na?
ইয়েস স্যার, আমি
So high pass sir, high pass.
Ah.
So you have seen that since it's a high pass filter, there is no attenuation at the when we choose the frequency to be very high. So you have to see the attenuation if you can take the frequency to be less than 400 hertz.
Okay. So frequency, as I told you, make it low. It's not a 1 hertz. You can make it a 50 hertz or
Yeah.
something like that.
Yeah. You gradually you change, and you will see that at 10 hertz the attenuation will be very high. At 50 it will be less, something like that. It will gradually uh, be more.
50 hertz.
Okay. So
No, in that case it will be you have to choose this waveform as sinusoidal. Mm. Yeah, you choose the frequency to be 10 hertz first. Let us see.
okay, just run that system. Is it connected? Sika, can you drag it up? Just function here, drag it up. Just okay. Is the positive set connected and output connected? Run that circuits and click on that oscilloscope. Double click on the oscilloscope.
No, in that you have changed the time base.
50 milliseconds. Right.
I think sir, she has selected the DC square wave.
Hmm?
I think he has selected the square wave.
Sir, the
Okay.
time base is too high. If we make it 50 milliseconds, it's coming fine.
The time base it's too high. Hmm. So you make it more, not in the in the other direction. Yeah. Yeah. Make it more. Make it more. Make it more. Yeah. Now just wait for some time. 50 milliseconds. No, you make it more. 100 milliseconds or so. Mm. Yeah. Now it's coming. Point 1 second or something like that.
Sir, can see off the channel A.
Are it to slightly less? Yeah.
Channel A off করলে ও বুঝতে পারবে আউটপুটটা কি হবে। চ্যানেল এইটাকে 0 করো তো।
Channel A, you make it 0. Channel A. You see the output. The output is almost 0. Now you make the this frequency say 50 hertz or 100 hertz.
So sir, she has selected the frequency 50 hertz here.
No, sir, 10 hertz.
So you can rise up. You can rise
Yeah,
up.
you go to 100 hertz. Yeah, 100. Yeah, let it be. You keep it there only. Leave it there. Doesn't matter. Then you run it and change the time scale once again.
Still the wave output is dying out. As it is a high pass filter, output is still dying out. And its cutoff frequency according to the student's calculation, it's a 400 hertz. Sudhasotto, can I rely on your calculations?
Yes, sir.
How will you? Okay. You did it. Fine. So, sir, output is dying out as according to the response of the high pass filter. As we have selected 100 hertz, it's better to get it close to the cutoff frequency. So, Sika, can you stop that circuits and increase the frequency of the function generator to close to that cutoff frequency and then more of that cutoff frequency? You will find that defined variations of the output waveform. And sometimes output waveform will not be there and sometimes output waveform will be there. Make it 400 or close to the 400. I think you can time over there 400 directly.
Yes.
Don't make it 400, 300 or 350. You will
Here
find.
there it is taken.
So output is not visible here. I mean, output is not there.
Yes.
It's still 0. So stop it again. What is the hertz? Is that a hertz or F hertz? Something written there, F hertz, I think.
Yes, sir. Cliff Hodge.
It's not hertz.
No, it should be hertz. Yeah.
8J. So now output is like.
Yeah, that was the mistake. It was femtohertz. So the frequency was too low. Yeah, you change the time division.
Hello, I'm listening. What about you?
You change the time scale. You change. Yeah. And now make channel A on. You change the time base.
Sir, you need to stop or pause the circuits, otherwise the value will change. No? Is that AC signal? No? So
Yeah, there is some acceleration. You can see here.
although that signal is close to the 400 hertz, am I right, Sika?
Yes, sir. 410.
This is near to 410. So it's a cutoff frequency. So gradually you will find that signal will come to that initial value when the frequency will be more than of 400 cutoff frequency. So right now, what you can see, you can once you can stop or make the channel be 0 to see the input frequency signals, and then after you can even make the channel A0 to see the value and waveform of the channel B. I mean output of the circuit. So this way you can see the output and input as well as you. And that is expected that sir will advise you to do select a sir. What kind of graph they will do here? Frequency response, amplitude response, like that.
Yeah. Frequency response means you have to take the gain input versus sorry output versus input at different frequencies to plot the frequency response. Okay, so in the frequency response, the x-axis will be frequency, and the y-axis will be the gain. And this gain is measured in dB. So in decibels, so you have to convert it into 20 log output by input voltage. And the x-axis, this frequency is plotted in logarithmic scale. So you have to take a semi-log graph paper, and in the semi-log graph paper, the x-axis will be frequency, and the y-axis will be gain in decibel. Right. So that you have to plot for this low pass filter and high pass filter with RC.
Okay, sir.
Now, sir, whether they will do this one over the software graph, I mean, soft copy of the graph paper, or they will bring some graph paper and will do manually with the plotting over that, and then after they scan and submit as a report. Sir,
It,
what?
it, yeah, it's better they do it. I mean, you buy the seminar graph paper and then plot it. You please practice that. That will be useful. Because later also you have to plot the this frequency response for many other systems, in control systems and in other papers also. So you please start practicing. And if the similar graph paper is not available at the present moment to your nearby places, because these graph papers are available only at Jadavpur University stores. These are not commonly not available. Then the second option is the software version. But try to practice with seminar graph paper. Okay, there is
Sir,
specific reason for that.
sir, in addition, I can say they can search the log paper or semi-log graph paper over the internet and Google image, and then after
Yeah,
download and take a printout and do that manually.
yeah, yeah, yeah,
It's
yeah.
only
Yeah,
that.
that is also a good idea. That is also a good idea.
Okay, this is a one assignment that you have to do. This is also fast order high pass filter. So we have a different objective as the fast order low pass filter, fast order band pass filter, as well as fast order high pass filter. And you have to do that graph paper as I've told you to submit this one. So before this one, you have to write over the theory. There will be certain part of that your lab report. Sir may explain that one. Uh, Sir, which part they will write on that graph paper, write on their lab paper? The theory as well as components required and circuit diagram and their analysis. Is it?
Yes, yes. Very briefly, not much. And I think we can give them some values of these components for this low pass filter and high pass filter. You can choose. Yeah, you can choose the value of this capacitor to be 0.47 microfarad that you have taken, and the resistance to be 1 kilo ohm. And based on that, you select the high pass filter and low pass filter and analyze the systems.
As they are doing virtually, so
Hmm.
is it better that they will take the last three digit as a value of resistance of their roll number? I mean, last three digit of their roll number as the value of resistance.
Yeah.
If they may try, then I mean, they will not copy and they will do their cycle. I mean,
Yes. That is also a good idea. Last three digits as the
so
resistance.
last
Sir,
सर
yeah.
लास्ट थ्री तो थ्री फर्स्ट डिजिट है तो जीरो सर तो लास्ट टू डिजिट बोले वाला सर
Last three digit কোথায় জিরো তোমাদের?
सर
sir,
फर्स्ट जीरो
0
है
থেকে
फर्स्ट डिजिट है जीरो
100
হবে
স্যার সবাই 0 থেকে 100 এর
तो
মধ্যে।
जीरो থেকে স্টার্ট হবে স্যার লাস্ট থ্রি ডিজিটস
ও তাহলে ফার্স্ট থ্রি ডিজিটে কি চেঞ্জ আছে না তাও নেই change?
না স্যার
ওটা
ওটা
সেম
same
স্যার
আছে।
সবার স্যার ওটাও জিরো দিয়ে স্টার্ট স্যার
ঠিক
No,
আছে
no,
তাহলে
there is absolutely no problem. You take the last three digits and take it kilo ohm. Say, for example, the first roll number will have 1 kilo ohm
अच्छा अच्छा
resistance.
হ্যাঁ হ্যাঁ
Second will have 2 kilo
স্যার
ohm, 3 kilo ohm,
স্যার
and so
একটু
on.
প্রবলেম হয়ে যাবে
কি
স্যার
problem হবে
একটু
বলো?
দেখুন স্যার
হ্যাঁ
একজন যার রোল নাম্বার 100 সে 100 কিলো ওহম ইউজ করবে।
হ্যাঁ,
হ্যাঁ,
কেন তোমাদের কত অবধি আছে 1 থেকে?
102 অব্দি আছে স্যার, আর বাকি হ্যাঁ 102 অব্দি আছে।
আচ্ছা,
স্যার লাস্ট 2 ডিজিটস দিয়ে দিন স্যার, ওটা ঠিক হবে।
স্যার
যে
লাস্ট 2 ডিজিট কিলো ওহম নাকি?
যার ওরকম স্পেশাল রোল নাম্বার আছে হি শুড এক্সপ্লেন, মানে ও কি কেন ওই ভ্যালুটা নিয়েছে সেটা এক্সপ্লেন করে দিবে, যেহেতু প্রত্যেক 3 ডিজিট হবে ডেফিনেটলি। সাইজা বললেন 2 ডিজিটটা ওরকম নেবে, যার 3 ডিজিট আছে সে 3 ডিজিটে গিয়ে ও হয়ে যাবে। ঠিক আছে, ওটা স্পেশাল সেন্সিটিভ হবে, মানে ও যেহেতু লাস্ট ডিজিট জিরো, তো 2 ডিজিট জিরো বললো তোমরা, এরকম কেউ আছে সত্যি?
হ্যাঁ স্যার আছে স্যার, 100, 101, 102 আছে।
যে 100 এর জন্য স্পেশাল কনসিডার হবে, ওটা 100 ওহম ধরবে, আর 102 ওহম ধরবে।
হ্যাঁ
okay. I'll confirm one formula. If the roll number is has only two zeros, in the last 3 digits, then you can consider the capacitance value to be higher. Hmm. I'll send you the this formula.
Capacitance value will be same for all.
Right? Sorry.
Will the capacitance value be same for all?
No. There may be some not exactly problem since you are doing it. I mean, theoretically, the only thing is that if the resistance changes over I mean, if the variation is huge, then the cutoff frequency will vary widely. So we can restrict that by changing the capacitance value in a similar way. For example, say those who have the roll number starting, I mean, 2-digit roll number, then they can have the capacitance value to be 0.47 microfarad. Those who have the roll number with only 1 digit, they can have the capacitance value to be, say, 1 microfarad. And the 3-digit roll numbers will have the capacitance value to be 0.01, something like that. That I'll frame and send it to you. Okay. So let us have different combinations. That will be interesting.
Sir, as sir told, you just follow this ones according to what the assignment will be sent to your mail account today, and I will receive the calculations of your designing of your particular circuit according to the value. Sir will suggest you, sir will advise you, and do it, and prepare your report. Send a particular mail address. I will create a mail address for that particular laboratory, and you should send your lab report there. Okay. When you will send the lab report, you just make a title clearly, as we can understand that this roll number students, or we can select the submitted copies directly from our inbox to put it in the folder of assignment 1 or assignment 2, anything. Okay. So this way we will collect your lab report from you to our particular mail address. I will share that mail address and I will send that assignment as sir will advise to you all. Okay.
So when we need to submit this?
Definitely before next week. I mean before next week.
Okay.
Yeah, before next Tuesday. Before next Tuesday.
So sir, anything more? Can I stop here?
Yeah. So the assignment is only on the high pass filter and low pass filter.
Okay. Is it only our band pass filter? Is that need to be designed here?
No, not now. Let them do it first because they may need some time to get acquainted with the software. And after that, we can do the other experiments, the band pass filter and this rectifier, full wave rectifier, half wave rectifier, and all that.
So then, as they have designed already the first order today, so will we make it second order?
Second order, yeah, that they can try. That also they can try. But in that case, the values have to be given, no, so from our side.
Yeah.
I think for the time being, let us, I mean, initiate with the first order system only, RC, high pass and low pass. And in the next week, we'll see. We can discuss the next assignments.
Okay, sir. Okay, sir. AG sir, will add anything here? AG sir. AG sir, are you there?
হ্যাঁ বলো।
স্যার কিছু অ্যাড করার?
না না, কিছু অ্যাড করছি না, খুব ভালো ক্লাস নেওয়া হয়েছে। এবারে ছেলেদেরকে অ্যাসাইনমেন্ট দিলে ওটা করুক, তারপরে কি করে রিপোর্ট সাবমিট করা যায় একটু তোমরা ভেবে দেখবে আর কি। এবং
স্যার আর
এটা
কিছু হতো কি? আর কিছু অ্যাড করতে হতো? ওরা
না 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 না, খুব ভালো হয়েছে, ভেরি গুড, ভেরি গুড, খুব ভালো হয়েছে। অ্যাটেনশন স্ট্রেংথ অলসো গুড।
স্যার তাহলে আজকে স্যার স্যার
ঠিক আছে, I'll calculate this RC values and send it to someone of you.
Okay, Joydeep, and all students, as I told you that I will create a mail ID to what we will communicate with you. কারণ তোমাদের সবার যদি প্রত্যেকটা অ্যাসাইনমেন্ট আসে তাহলে 57খানা করে অ্যাসাইনমেন্ট আসবে ইনবক্সে, আমাদের পার্সোনাল মেল বক্স পুরো ওভারফ্লো হয়ে যাবে, আমাদের জরুরি মেলগুলো আসে। So we'll use as another mail address for this one, and we'll send you the assignment as such told to you all, and you can submit or you just submit your all assignment to that particular mail address. Don't send it to us directly, you just send it to that particular address, and we can even use the drive to get your work. But you do your calculation yourself, you are here to learn something, so do that calculation here. Is that
কি বলে দাঁত মাথা হয় না, আমি করতে হবে তখন চলে যাবো তোর কাছে কাজ।
So that's all today. Sita, can you stop your presentation? I can take it attendance.
Yeah. Okay. Thank you, students, for attending.
Okay, I am taking a screen as your attendance today. You are here with 49 number of students, and Joydeep, we inform everyone that we have started our laboratory class this way.
Yes,
And
sir.
software to everyone as if they can come over here, and we can select one or any one of you to display how they are doing that laboratory work. Okay. Like today, Sita did it, and tomorrow might be Soham Kanji or Boivov, might be Biplav Sarkar, might be Nilagro. They all should be ready how to design that software. Okay. No excuses will be considered that time. We are strict on that case. Okay. Thank you. I'm taking that your all attendance over here. As sir told you, we are dropping our class here. So meet you next week.
Sir, instead of sending assignments over the mail, so you can send us the Google Drive folder. It will be better for you all also to check, and it will be arranged as per the sequence of roll numbers.
Yeah, I know. Sometimes what happened, we have to give you permissions. For what we have to open our mail and allow you to access the Google Drive. This way we used to keep touch with the mail or drive. That is a very irritating job because we have some other job to finish that time. Okay, that's why
Sir, there is one feature, sir, of managing the links. So you can change that to access everyone as editor. So once everyone completes uploading their documents, you can change the link to private. That is only for you.
That's a job, no? That's a extra work we have to do.
That's just only one time, sir. You don't need to do it for everyone. Only when you are creating the drive folder, you can change the setting. Only once you have to do that.
Okay, we can do it. I'll try my best to do this one.
Okay,
Sir, or else we can also send a drive folder to you. It will also be, like we did with our IE workshop.
Yeah. You can share your drive like last day you did. First day you did. No, I have taken your
So in
attendance this one.
yes, sir. Yes, sir. So in second year also we had instrumentation electronics workshop. There also we send our assignments to Shubhankar sir is this way only. We created a drive folder and we send that drive folder to him.
Okay, you can do this one, but let me open a particular Google Drive
Yes, sir. Yes, sir. Yes, sir.
account
You can do that.
drive that one. Okay. Okay, thank you. As I told you that we will meet in next week with your lab report and do the lab report. Remember, sincerely as well as you download the log paper, do practice with the amplitude response, frequency response over the log paper. This is very important task. You have to do it. Okay. Thank you all.
Yeah. Okay. Thank you for taking class. Yeah.
Thank you, sir.
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 Thank you, sir.